The gypsy woman told my mother before I was born, I got a boy child's coming. He's gonna be a son of a gun. He's gonna make pretty women jump and shout.
Okay, time for section 2.4, the product rule. So we're looking at another rule here to help us calculate derivatives quickly. So based on what we did last day, when we did the sum and difference rules, the following may seem obvious to you. If we want to know the derivative of the product of f and g, based on what we did last day, what might you think it is equal to? You might think it's equal to f prime times g prime, right? That would kind of match up with what we did last day. Well, let's see if it's true. Let's do just one little experiment and see if we can make it work or not. So we have two functions here. One's f of x, which is equal to x, and one's g of x, which is equal to x squared. Some pretty basic functions. So let's figure out what the derivative of f of g of x is, and then we'll see what the derivative of f of x times the derivative of g of x equals, and they should be equal to each other in order for this to be true. Okay, well for the first one, what we have to do is we have to find what f times g of x is first. So I don't know, where am I going to put this? I'll put it over here. Fg of x, well, to get that you just multiply together x times the x squared and you get x cubed. So then if we want to get the derivative of fg of x, all we have to do is take the derivative of x cubed. So maybe what I'll do here is I'll put d dx of x cubed, and when we get that we get 3x squared. Okay, to do this one, we have to take the derivative of the f function. Well, the derivative of the f function is 1, and we're going to multiply it by the derivative of the g function. Well, the derivative of the g function is 2x. We multiply those together and we get 2x. So this one is 3x squared, this one is 2x. They're not equal to each other, so these two things up here that we've written are not equal to each other. No, this is not the way we do product rule. The product rule actually is a little bit more complicated than that. It looks like this. If we're looking for the derivative of f times g, what you have to do is take the derivative of f and multiply it by g, and then you're going to add on to that f times the derivative of g. Now, I'll let you know that most books I find actually don't write it that way. They write it slightly different. They would write it like this. They say it is fg prime plus f prime g. Now, as you well know, when you add, order doesn't matter. So this is exactly the same thing. The reason I like to do it this way is because later on, next day, we're going to learn the quotient rule. And with the quotient rule, you're going to have two terms in the numerator like this, and you're going to subtract. When you subtract, order does matter. And this is the order they're in the quotient rule. So I like having the same order for the product rule and the quotient rule. So this is the Waj way, I guess. I'm not the only one who does that, but I do find this one over here is much more common. I can't really figure out why. Okay, the other way you could write this, remember this is totally equivalent, it's just another way of writing it. You could say that the derivative of f of x, g of x is equal to the derivative of f of x times g of x, and then add on to that f of x times the derivative of g of x. It's certainly a lot more work to write it, isn't it? But it means exactly the same thing as this. You can probably see why most people prefer this. We're going to do the same question we did up here. We're going to do it this time using these formulas, or one of those formulas anyway. So what we just saw is that the derivative of fg is equal to, I guess I could write it again, f prime g plus fg prime. Well, f prime is the derivative of x, it's just 1. G, there's g right there, it's x squared, plus f, here's f, it's x, times g prime. Well, g prime is, if you use the power rule, 2x. So what you end up with is x squared plus 2x squared. You get 3x squared is your answer. And if you look back up here, you will see that, yep, it's absolutely true, 3x squared is our answer. So remember, this method here was wrong. Can't do it that way. All right, let's do a few more questions on the back. Find d dx, in other words, find the derivative if y equals 2x cubed plus 5 times 3x squared minus x. So it's a little bit more complicated. But basically what you're doing here is you're multiplying two things together. You're multiplying together 2x cubed plus 5. So if you want, you could think of that as like your f. Your f amount is 2x cubed plus 5, and you're multiplying it by this, the 3x squared minus x. Why don't we think of that as our g? 3x squared minus x. And we're going to use the product rule because they're multiplying. So I'll write it again just to kind of help you remember it. F prime g plus fg prime, or switch those two terms around if you like, and away we go. We take the derivative of f. Well, the derivative of f, we use the product rule here, we use the power rule here, so that's 6x squared, and then we take the derivative of 5. Well, that's just a constant, so we get 0. No need to even put it. We're going to multiply that by g. Well, here's g right here. It's 3x squared minus x plus f. Well, here's f right here. 2x cubed plus 5. And we multiply that by the derivative of g. So the derivative of g, first of all, using the power rule, this first term, 6x, minus, we're using the subtraction rule here, aren't we? The derivative of x is just 1. Okay, let's expand all this. You're going to have to do some distributive property there, some mountains and valleys, or whatever you call it there. So we end up with 18x to the fourth minus 6x cubed plus 2x cubed times 6x is 12x to the fourth. 2x cubed minus 1 times negative 1 is negative 2x cubed. 5 times 6x is 30x. 5 times negative 1 is negative 5. Now we're going to combine some terms. Let's do it in descending order. So the x to the fourths first. We have 18 and 12, which is 30x to the fourth. We have negative 6x cubed and negative 2x cubed, which is negative 8x cubed. We have no x squareds. We have 30x cubed. We have 30x, and we have take away 5, and I believe that's it. So we're going to use the product rule because we have one term multiplied by another term. Remember, you could also answer this, we did this before, by expanding this through to get two terms, and then just use the power rule after that. That's fine. I don't know, maybe it's even easier. But let's do it with the product rule. So first of all, it is going to be useful to switch this into a rational exponent. So the cube root of x squared is the same as x to the 2/3. And we're going to multiply that by 2x minus x squared. So again, you don't need to write this every time. Hopefully after, you can, but hopefully after a little bit you don't have to. You're going to ask yourself, what's the x and what's the g in this case? Well, the x is the x to the 2/3, and the g, what you're multiplying it by, is the 2x minus x squared. And we use the same old formula. Should I write it again? Oh, what the heck. Y equals f prime g plus fg prime, and away we go. So y equals f prime. So we're going to take the derivative of this. Power rule, 2/3 comes down, x, we subtract 1 from 2/3 and get negative 1/3. G, well, here's g right there, so we'll just rewrite that whole thing, plus f, there's f, x to the 2/3, and you're going to multiply that by the derivative of g. So the derivative of the first term is 2 minus, we use the power rule, the 2 comes down and you get 2x. Okay, the next step is kind of tricky, but we can do this. You're going to expand this, so multiply, and expand this. So y equals, okay, so the way we multiply this first two terms is 2/3 times 2, which is 4/3, and then negative 1/3, x to the negative 1/3 times x to the 1. What's the rule when you have the same base? You add the exponents. So since this is x to the 1, why don't we write it as x to the 3/3? Then it's easier to add. Negative 1/3 plus 3/3 is 2/3, so we get x to the 2/3. Okay, the next one. 2/3 times negative 1 is negative 2/3. X to the negative 1/3 times x squared. Well, again, we're going to add exponents. So this is 2. We want a common denominator of 3, so 2 is the same as 6/3. Yeah? So negative 1/3 plus 6/3 is x to the 5/3 plus, This is an easy one. 1 times 2 is 2, and you still have an x to the 2/3 left over, and x to the 2/3. Okay, so we have a 1 times -2, which is -2. Why don't we make this, since it's a 1, why don't we make it 3 over 3? Going to add the exponents on the x's, so 2/3 plus 3/3 is x to the 5/3. And what do you know? You get some common, some like terms here. We have x to the 2/3 and x to the 2/3. You got 4/3 of them here and 2 of them here. Oh boy, again, 2, if we get common denominators with the 3 on the bottom, 2 is the same as 6 over 3. So you have 4/3 plus 6/3 is 10/3, and we just keep the x to the 2/3 the same. Then we have minus 2/3 and minus 2/3 x to the 5 over 3 and minus 2 x to the 5 over 3, so like terms. Again, why don't we get common denominators? So it would be 6 over 3 again. Negative 2/3, take away 6/3 is negative 8/3 x to the 5 over 3. I think that's a pretty awesome answer. Want to do it even simpler? Why don't we have to do factor here? What can we factor out? Well, first of all, you've got a denominator of 3 in both terms you can factor out. You've got 10 and 8. What's the biggest thing you can factor out there? 2. So we can take out a 2/3. How many x's can you take out? What's smaller, 2/3 or 5/3? 2/3. So you can take out x to the 2/3. Okay, what are we left with in the first term? What do you have to multiply all this by to get this? What you have to multiply it by is 5. Because if you multiply by 5 over 1, you get 2 times 5 is 10, 3 times 1 is 3, and you still have the x to the 2/3 right here. Great. Minus, what do you have to multiply 2/3 by to get 8/3? You have to multiply it by 4. Now, this is a little tricky. What do you have to multiply 2/3 by to get 5/3? Well, remember, you would add the exponents when you're multiplying. So if you added 3/3, you'd get up to 5/3. Well, 3/3 is the same as 1, so you actually only have to multiply by x. That's a little tricky, that last little step there. But, you know, you should figure out how to do that. Okay, last one. Find the slope of the tangent to the graph of the function f of x equals 3x squared plus 2 times 2x cubed minus 1 at the point 1, 5. So, slope of the tangent, no problem. You know what the slope of the tangent means. If we're looking for the slope of the tangent to this function right here, then what you're interested in is what is the derivative of that function. How are we going to do that? You're going to use the product rule. You're going to do f prime g plus f g prime. Boy, I wrote that a lot here. What's your f and what's your g? This is your f, the 3x squared plus 2. This is your g, the 2x cubed minus 1. Let's do it. F prime. So we're going to take the derivative of this. First term, do the power rule, you get 6x. Second term, it's a constant, just 0. So that's done. G, here's g. I'm going to multiply it by 2x cubed minus 1 plus f, here's f, 3x squared plus 2. G prime. So we're going to take the derivative of this. First term, power rule, 6x squared. Second term, constant, just equals 0. Done. Let's use the distributive property here, and kind of going backwards, but it still works. Order doesn't matter when you multiply. 6x times 2x cubed is 12x to the 4th. 6x times negative 1 is negative 6x. 6x squared times 3x squared is 18x to the 4th. 6x squared times 2 is 12x squared. Combine the x to the 4th, you get 30x to the 4th plus 12x squared minus 6x. Now, that's fine. I know you're probably saying, well, why don't we factor this right now? And you can. Let's do it, and then I'll explain why you don't have to in this case. So if we were to factor this, we could take out a 6, and we could take out x. And then we'd have left 5x cubed plus 2x minus 1. So these are both great answers. But remember, this is what f, the derivative of f equals. And same here, it's the derivative of what f equals for any value of x. But we're not interested for any value of x. We're interested at the point 1, 5. So specifically, we're interested when we have an x value of 1. So what you would need to do now to get the actual slope of the tangent at that point is to plug that x value into the x's. So you can do it just as easily here in this one, maybe even easier than this one. So it's up to you which one you plug it into. It's so nice. They often give you 1 as the value you plug in. They are nice that way in the book because plugging in 1 makes it very easy. 30 times 1 to the 4th is just 1, so you get 30, plus 12 times 1 squared is just 1, so you get 12, minus 6 times 1 is just 6. So our answer would be 42 minus 6 is 36. Just to prove it to you, I'll do this very quickly. If you were to have done it in this one, you'd have 6 times 1 is 6, 5 times 1, 5, plus 2 times 1 is 2, minus 1. That's the same as 6 times 7, 6, which is 36. So it works. It doesn't matter. So if they give you the x value, I would recommend that you don't factor. It's just kind of wasting time. But if the question just said, find the derivative of this, for example, if it just said, what is the derivative of this, then we'd want it to be in the simplest form possible, and I would say that this would be the better answer. All right? There you go, everybody. That's the product rule. We're going to use that one a lot as well. Next day, the quotient rule, then the chain rule. You master those ones, this course is going to be a lot easier for you.